Okay, guys. So we have completed today the two-way ANOVA part. Okay. So Ujjal knows all these things. They are part of one-way ANOVA and two-way ANOVA. Seema also has learned today. Okay, Ujjal, I have told you now about this 2K HSD test that is used to check which groups are different. Can you tell me? I have forgot to ask you one question. Can you tell me what is this mean difference? This column. I have explained the reject part. Okay, that is why do we select the reject part as true here and in this case false. But what is this mean difference? Minus 3.72. Because when you conduct this, okay, for different number of trials, you are getting different means now. That is mu1 minus mu2 will be different. Okay. Out of 100 times, if 95 times, this difference is likely to lie within this lower bound and upper bound. Okay. So, and one of them is, if one of them is equal to 0, in this second case here, look, minus 7.2436 is your lower boundary and upper is 0.1236. So here one mean difference is that is there exists such difference in mean which is equal to 0. That is mu1 minus mu2 equal to 0. Okay. So but there may be some other type of means that have positive or negative value difference in mean. Okay, in both the cases. So you take mean of those difference in mean. Okay, mean of those difference in means, that becomes this mean difference. Okay, understood, Ujjal, Shima? Because you both have attended my session, that's why I have explained these things to you. Have you understood this mean difference now?
Yes, ma'am.
So this mean difference is all those difference in means need to be summed up and take a mean of that. Okay. Okay. So now we come to machine learning part. Okay. All the part which I have covered till now, including your hypothesis test, chi-square, non-parametric to parametric test, okay, and chi-square, ANOVA, okay, these are the part of basic data science, okay, and now we are going to cover machine learning related algorithms. So before doing that, we have to learn what is actually machine learning. Okay, what machine learning actually does in practice. Okay, so okay, so you have to understand first few things. Okay, some basic concepts. Okay, some basic concepts on machine learning. Okay, I'm sharing my screen. Just wait. Look, as a human, okay, this kind of stories build in you interest a lot. Okay, you can understand the different aspects of machine learning. Okay, let's suppose one day you went for shopping mangoes. Okay, the vendor means supplier, had a cart full of mangoes. Okay, from where you could hand pick the mangoes. Okay, get them weighed and pay according to the rate fixed per kg. Okay, so task, how will you choose the best mangoes? Okay, look, given below is the set of learning human gains from his experience of shopping mangoes. You can drill it down to have a further look at it in detail. Go through it once, you will relate it to machine learning very easily. Okay, first experience is what? You have to gain experience. Okay, that is how when you buy mangoes, then that experience helps you helps you decide that which mangoes are best, which mangoes you are going to pick. Okay, as you consider them best. Okay, so look, experience one, you were informed that bright and yellow mangoes are sweeter than pale and yellow ones. Okay, understood? So you make a simple rule. Pick only from the bright yellow mangoes. You check the color of the mangoes, pick the bright yellow ones. Pay up and return home. Right? Now, when you went home and tasted the mangoes, some of them were not sweet as you thought. You are worried as your wisdom was insufficient. Okay. You concluded that when it comes shopping mangoes, you have to look for more than just the colors. So color is an attribute which you have considered for the first time, but now taste is another attribute which you have to consider. You have understood the same. Okay, after a lot of pondering and testing different types of mangoes, you concluded that the bigger and bright yellow mangoes are guaranteed to be sweet, while the smaller bright yellow mangoes are sweet only half the time. That is, if you bought 100 bright yellow mangoes, 50 will be big in size and rest 50 will be in small. Then the 50 big mangoes will all be sweet, while out of the 50 small ones, only 25 mangoes will turn out to be sweet. Understood? Have you understood, Ujjal, Shima, Bidisha, Rajkamal, Shubham?
Yes, ma'am.
Yes.
So out of 50 small mangoes, only 25 mangoes will turn out to be sweet. Okay, but if the size of the mangoes are big, then out of these 50 mangoes are sweet. Okay, 50 big mangoes are sweet. Okay, so but in case of small 50 ones, okay, only 25, that is half of them will turn out to be sweet. You will then update your rule about the mango shopping, and from next time you will keep this in mind. So it is your so two factors are important in machine learning. One is your experience level, another is framing rule, how you are framing the rule. Okay, why do you need to frame rules? To act, to conduct any test, or to do some action, to take some action, you need to frame rule. Okay, based on your experience level. And also you have to meet the specific objective. Okay, that is buying the best mangoes. Okay, if your objective gets changed, then then you have to use your experience level also, but you have to frame different rules. Okay, if I tell you to select worst mangoes, then obviously you have to frame different rules, but your experience level is same. Okay, that is whatever experience you have gained, you have to frame the rules in a reverse manner. Okay, that is what I am telling you, that framing rules is most important, and it varies from situation to situation. And it is up to you keeping in your mind the objective. Okay, if you don't know the objective, the specific objective which needs to be met, then you cannot frame the rules properly. Okay, so look at this experience 3. That is, next time at the market, you see that your favorite vendor has gone out of town. Okay, you decide to buy from a different vendor who supplies mangoes grown from a different part of the country. Now you realize that the rule which you had learned, that is big bright yellow mangoes are the sweetest, is no longer applicable. You have to learn from scratch. You taste a mango of each kind from this vendor and realize that the small pale yellow ones are in fact the sweetest of all. because these small pale yellow belong to these small pale yellow mangoes belong to a different zone of your country, and they are the sweetest of all. So now again your experience level gets increased. Okay, you have just improved your experience level. So now you are framing the rule in a different way. Okay, so whatever experience you are gaining, you day by day you have to improve your experience level, but you have to frame your rule, okay, according to the according to the situation uh, and time, and also you have to keep in your mind what sort of objectives, what sort of specific objectives need to be met. Okay, now the experience 4. One day your cousin visits you from another city. You decide to treat her with mangoes, but she is like, I don't care about the sweetness of a mango. I only want the juiciest ones. Okay, the juiciness. Now, once again, you run your experiments, testing all kind of mangoes and realizing that the softer ones, okay, the softer ones are juicier. Experience 5. Later on, you move to a different part of the world and you found that, okay, the mangoes you test, okay, you find out there that the mangoes here taste surprisingly different from your home country. You realize that for this country, the green mangoes are tastier than the yellow ones. Again, there is a small change in your rule, okay, which is required. So experience 6. You may someone who hates mangoes but loves orange or apples instead. Okay, so you marry someone who hates mangoes but loves orange or apples instead. Now you go for shopping orange or apples instead of mangoes. Okay, now all your accumulated knowledge about mangoes is worthless. Okay, that is of no use to you. Now you have to learn everything about the correlation between the physical characteristics and the taste of apples by the same method of experimentation. Okay, that is the size, color, taste, juiciness, ripeness of the apples and oranges. Okay, so this is the case, and here you can have to understand the differences because you have made a clear picture. Okay, that what an apple looks like, what a mango looks like, what is the taste of an apple or of an orange or of a mango. So this is how you keep in your mind a clear picture of these fruits. Okay, so so what is the conclusions as a human being? You have experimented all these fruits, so to learn what sort of fruits these are. Okay, the ripeness, the size, the and look for those best mangoes or best apples or best orange. Okay, so what will be the conclusion as a human? But every time you make a new observation from your experiments, you have to modify the list of rules manually. Okay, so improvement level of experience gets increased. Okay, that is improvement of the experience gets increased when you that is when you gain some new experience in addition to your existing experience, then you can improve your understanding level and you have to frame the rules or rearrange the rules. Okay, again, so as to fit it in the current situation so that the specific objectives can be met. Okay, so this is the conclusion which a human being can draw. from this sort of experiments. Now you have to understand the details of all the factors affecting the quality of mangoes. Okay, if the problem gets complicated enough, it might be difficult for you to make accurate rules by hand that covers all possible types of mangoes. This will take a lot of research and effort, and not everyone has this amount of time. This is where machine learning comes into the picture. Okay, so what is machine learning? Understood? Because you cannot frame accurate rules. Now there are many rules. This is sweet by 15%, this kind of mangoes. Some mangoes are sweet by 48%, some mangoes are sweet by 38%. So, and then juiciness, then color, then origin, where these mango plants are born. Well, then come your size, then ripeness, everything. A lot of things, a lot of attributes get added, and their percentage obviously vary from each other. Okay, so making accurate rules is very tough if you do that by hand. So here you have to use this machine learning. Okay, so what is machine learning? It is a concept which allows the machine, okay, you have to automate the machine, okay, to learn from examples and experience, and that too without being explicitly programmed. Okay, you are, when you write a snippet of code to and make it executable, that when you run the code, when you debug and run the code, you will get the output which you have, which you desire. Okay, which is desired. Okay, so that you want to obtain the desired output, so you code according to that, according to meeting your specific specific objective. That is, the snippet of code which you are writing should give you the desired output. But in case of machine learning, you don't have to write such code. Okay, you have to make the machine automated. How? That the machine should learn from examples and experience. Suppose your machine is fed, okay, your machine is fed with a training data set. Then what will you have to do? That is, you have to feed the machine with the training data sets. Okay, so the machine from that training data set just tries to learn what sort of data, what sort of output it will deliver. Then that output or other type of examples and experience, okay, related data will be fed, okay, as an input again. So in this way, gradually they improve their experience level from different insights and examples. Okay, and then they will better analyze what sort of output they are going to deliver. Okay, they are going to give you. Okay, so when I will explain this thing in detail, then you can better understand. So here we don't need to write any explicit, we don't need to write any program explicitly. Okay, that is, you have given some input and you will get output. This is not the case here. When you are giving some input and getting output, that experience level, the output will be fed again as an input for improvement of the machine, so that it can better give some results. Okay, it can give better results. And again, though that experience or the output which you are getting is again fed to the machine as an input. Okay, so instead of you writing the code, what do you do is you feed the data to a generic algorithm, and the algorithm formation builds the logic based on the given data. That is, suppose you have given some sort of data, attributes, related values. So based on that, the machine will decide that what what sort of output it has to deliver. Okay, so the machine itself builds the logic. You don't need to write the coding part. To that is the logical part. That is, you don't need to write any code related to the logical part. Okay, the machine itself builds the logic on the given data. Okay, understood? So you have to do one thing, that is feed the data to the generic algorithm. Okay, and the algorithm or machine itself builds the logic based on the given data. Okay. Now look at this. So machine learning enables the machine to automatically learn from data, improve performance from experiences, and predict things without being explicitly programmed. Okay, predict things without being explicitly programmed. Okay. Machine learning algorithms are an evaluation of normal algorithms. Okay, then they make your program smarter by allowing them to automatically learn from the data you provide. So the algorithm actually is mainly divided into training phase and testing phase. Okay. Now look, what is this training phase? You take a randomly selected specimen of mangoes, okay, from the market, that is training data. Make a table of all the physical characteristics of each mango, like color, size, shape, grown in which part of the country, that is origin, sold by which vendor, okay, etc. features, along with the sweetness, juiciness, ripeness of the mango. That are your output variables. Okay, that is, you have to check the sweetness, juiciness, ripeness. Okay, these are the things which you have to check. Okay, you feed this data to the machine learning algorithm. Okay, so here you have to feed, look, along with the sweetness, juiciness, that is your output variable. So you have to feed your data to the machine learning. You have to feed this data to the machine learning algorithm, either classification or regression. So feed this data means features along with these output variables. Okay, features and along with these output variables. You have to just feed this data. Okay, and it learns a model of the correlation between an average mango's physical characteristics and its quality. Okay. So now come to the testing phase. What does this phase do? Next time when you go shopping, you will measure the characteristics of the mangoes which you are which you are purchasing. Okay, that is test data, and feed it to the machine learning algorithm. It will use the model which was computed earlier to predict if the mangoes are sweet, ripe, and or juicy. Okay. The algorithm may internally use the rules similar to the one you manually wrote earlier. For example, a decision tree. We will cover that later. Okay. But you know the decision tree algorithm, there are different nodes. Here we do some sort of programming on decision tree, but if you want to do decision tree manually, I think you guys have done these things a little bit. Okay. Yeah, in software engineering or some related topic. Okay, that is there are main node is divided into two node. Okay, based on some weightage. Okay, we categorize those values to different nodes, and again sub node, children node. So this is your decision tree now. So so finally you can this is how we move from top to bottom. Okay, and reach to the unique elements. Okay, so that's a different thing. I am telling here that the algorithm here use internal rules to decide. Okay, to predict the output. Okay, finally you can now shop for mangoes with great confidence without worrying about the details of how to choose the best mangoes. Okay, understood. Training phase and testing phase is clear. For the improvement of your model, you need to feed the algorithm or feed the machine with this test data. Okay. Okay. Now the conclusion as an algorithm is what? The conclusion as an algorithm is, you know what, you can make your algorithm improve over time. That is reinforcement learning, so that it will improve its accuracy as it gets trained on more and more training data set. Okay. In case it makes a wrong prediction, it will update its rule by itself. Okay, the best part of this is you can use the same algorithm to train different models. Okay. You can create one each for predicting the quality of apples, grapes, bananas, or whatever you want. Okay. Because I have mentioned now, generic algorithm, the word. So you have to feed only the input data and the feature data and the output variables to your machine. The generic algorithm itself creates logic to and predict the output. And these are the models. Based on the same algorithm, these are the models for different fruits, for predicting the quality of apples, grapes, bananas, or whatever you want. Look, this is the word generic algorithm. What you do is you feed data to the generic algorithm. Okay. And you can use this generic algorithm, that is the same generic algorithm is used to predict quality of different fruits, quality of apple, orange, or whatever you want. Okay. So you can use one particular generic algorithm and build different models. Okay. Understood? Now come to this part. What is there may be confusion between these three terms among if you don't understand what difference exists or what difference is lying between AI, ML, and deep learning. So just overcome the just don't get confused here, just try to understand. Actually AI, ML, and deep learning are something the superset and subset concept. So it is like that. Okay, one is subset of the other superset. Okay, so just go through. AI, ML, and deep learning are not same. Okay, what is artificial intelligence? Artificial intelligence is the broader concept of machines being able to carry out tasks in a smarter way. Okay, it covers anything which enables the computers to behave like human. Okay. So machine learning is key. Machine learning is a subset of AI and is based on the idea that machine should be given the access to data and should be left to learn and explore for themselves. Okay, that is from the given data. Okay, it deals with sorry, it deals with the extraction of patterns from a large data set. Okay, these extraction of patterns are nothing but building the logic. Okay, the machine is building the logic. Okay, that is the extraction of patterns from a large data set. Okay, so that is framing the rules. Okay, that is your extraction of patterns. Okay, deep learning is what? Deep learning is a subset of machine learning. Machine learning is a subset of AI, but deep learning is also subset of machine learning. Okay, where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Okay. So to understand deep learning versus machine learning, you must know the difference between machine learning and deep learning. And the major difference is that we need to provide the features manually in machine learning, but in deep learning, it automatically extracts features for classification, which in turn demands huge amount of data for training deep learning algorithms. Understood? For machine learning, we have to add manually the features. Okay. But in deep learning, it automatically extracts features for classification. Okay, so that's why it requires a huge amount of data for training deep learning algorithms. So in deep learning, the accuracy of the output depends on the amount of data. The more amount the training, the more amount the training data set is having, the better the result is. Okay. The better the result you will get. So let's categorize machine learning into its subparts and see what each of them are. Okay. How they work and how each one of them is used in real life. Okay. So first learn supervised learning. Just go through. So, have you all gone through? Ujjal, Ujjal,
Yes, ma'am.
what have you understood?
Supervised machine learning.
Yes, yes.
Yes, ma'am. I have to explain.
Understood? Just tell me whether you have understood or not. Ujjal, have you understood?
Understood. Yes, ma'am.
Okay. Rajkamal, you have understood? Look at this figure. This is input data, okay? So it is your training data set, okay? This is the supervisor derived output and that is fed into this machine. So the generic algorithm just process this, okay, just trains the model, okay, just builds the model, okay, and this is the output, okay. So it is an apple, okay. So when you input data X will be fed, the machine can easily predict that the output variable Y, okay. So in supervised machine learning algorithm, every instance of the training data set consists of input attributes and expected output, that is the predicted output, okay. The training data set can take any kind of data as an input, like values of a database row, the pixels of an image, okay. Or even an audio frequency histogram. Here we don't need such attribute, but for different types of predictions, you need to learn these things. Okay. So now let me tell you why this category of machine learning is termed as supervised. Okay. The category is termed as supervised learning because the process of an algorithm learning from the training data set can be thought of as a teacher teaching his students. Look, there is a supervisor now. So, this category is termed as supervised learning because the process of an algorithm learning from the training data set can be thought of as a teacher teaching his students. Okay. The algorithm continuously predicts the result on the basis of training data and is continuously corrected by the teacher. Okay. So continuously corrected by the teachers means by the algorithm. Okay. The learning continues until the algorithm achieves an acceptable level of performance. Understood? So this is one use case of supervised learning. Hi, I am Cortana. Ask me a question. Cortana or any speech automated system in your mobile phone. Okay. Trains your voice and then starts working based on this training. Okay. Cortana or any speech automated system. Okay. In your mobile phone trains your voice and then starts working based on this training. This is an application of supervised learning. Now, weather apps predicts the upcoming weather by analyzing the parameters for a given time on some prior knowledge. When it is sunny, temperature is higher. When it is cloudy, humidity is higher. Okay. So when it's sunny, temperature is higher. When it's cloudy, humidity is higher, etc. So these are the parameters need to be taken into consideration. Okay. So based on that, you have to predict the upcoming weather by analyzing these parameters. Okay. This biometric attendance. In biometric attendance, you can train the machine with inputs of your biometric identity. Okay. It can be your thumb, iris, or earlobe, etc. Once the machine is trained, it can validate your future input and can easily identify you. Okay. Once the machine is trained, it can validate your future input and can easily identify you next time. Understood? Now, what do you mean by unsupervised learning? Go through. Look, unsupervised learning is where you only have input data and no corresponding output variables. Okay. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. That is, hidden pattern, underlying pattern needs to be discussed here. Okay. You don't know about you don't know why, so you cannot predict why. The goal for supervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. Look, unknown output, no training data set. Okay. So algorithm just trains with the input raw data, process it, and just categorize. Okay. based on some characteristics. It will not give any specific output. Based on some characteristics, it will just categorize, like it will form cluster. When we do clustering, then you can understand. In case of clustering, you don't have any definite output. You don't know that is what sort of cluster you can frame. If you define that I want 3 clusters or 4 clusters, so the machine itself just creates 4 clusters, keep those elements having similar kind of characteristics in respective clusters. Okay, so let me rephrase it for you in simple terms. In the unsupervised learning approach, the sample of a training data set does not have an expected or predicted output associated with them. Using the unsupervised learning algorithms, you can detect patterns, okay, based on the typical characteristics of the of the input data. So based on the typical characteristics of the input data, you just draw out some sort of patterns, okay, and based on those patterns you just do clustering. So clustering can be considered as an example of machine learning task that uses the unsupervised learning approach. The machine then groups similar data samples and identify different clusters within the data, okay. Now let me tell you why this category of machine learning is known as unsupervised learning. Well, this category of machine learning is known as unsupervised because unlike supervised learning, there is no teacher. Algorithms are left on their own to discover and return the interesting structure in the data. Look, unknown output and no training data set, okay. That is no data set with predicted or expected output, okay. Only some raw data will be fed into the machine. Or you can say input raw input data are fed to the generic algorithm. Or the raw input data passed to the generic algorithm or fed to the machine, whatever you want to say. But there is no predicted or expected output is present, okay. So what are the use cases of unsupervised learning? Just go through. A friend invites you to his party where you meet totally strangers. Okay, now you will classify them using unsupervised learning, no prior knowledge, and this classification can be on the basis of gender, age, group, dressing, educational qualification, okay, or whatever way you would like. Okay. Since you did not have any prior knowledge about the expected output or and about the characteristics, okay, so you just classified them on the go. Okay, let's suppose you have never so if you feed this type of data to the machine, then the machine itself will cluster itself will frame different clusters, okay, on the given input data, uh, say x data set, okay, and based on that it will form clusters. So put the similar put the put your set a particular set of friends having similar characteristics in one cluster and having different types of characteristic in some other clusters, okay. So now look at the second example. Let's suppose you have never seen a football match before and by chance watch a video on internet. Now you can classify players on the basis of different criteria, like players wearing the same sort of kits are in one class, players on one style are in one class. Okay. So players of one style are in one class, players, goalkeeper, referee. Okay. Or on the basis of playing style, attacker or defender, or whatever way you would observe, you can classify it. Okay. So now come to the reinforcement learning part. So what is reinforcement learning? Just go through. What is reinforcement learning? Have you understood? Have you all gone through? Reinforcement learning can be thought of as a hit and trial method of learning. The machine gets a reward or penalty point for each action it performs. Okay, if the option is correct, the machine gains a reward point or gets a penalty point in case of a wrong response. Understood? Ujjal? Understood? Shima?
Yes, ma'am.
Just look at the figure. This is the input raw data apple or not. Okay, confused person. Okay, confused robot. Then this is the environment. Okay, the agent. Okay, look, selection of algorithm. Okay, so this is the reward state, the state. Okay, and this agent just selects the algorithm and then based action be taken on the environment. Okay, so this is the model trend. It is an apple. Okay, this is the output. So the reinforcement learning algorithm is all about the interaction between the environment and the learning agent. Okay. The learning agent is based on exploration and exploitation. Okay. Exploration is when the learning agent acts on trial and error, and exploitation is when it performs an action based on the knowledge gained from the environment. Okay. The environment rewards the agent for every correct action. Okay. Which is the reinforcement signal. With the aim of collecting more rewards obtained, the agent improves its environment knowledge to choose or perform the next action. Okay. So let's see how Pavlov trained his dog using reinforcement training. This example will clearly let you understand, okay, what actually reinforcement training is doing in practice. Okay, how reinforcement training works in practice. Okay, so Pavlov is divided. He works on machine learning. Pavlov is a man. Okay, so divided the training of his dog into 4 stages. Okay, in the first part, Pavlov gave meat to the dog, and in the response to the meat, the dog started salivating. Okay. In the next stage, he created a sound with a bell, but this time the dogs did not respond anything. In the third stage, he tried to train his dog by using the bell and then giving them food. Seeing the food, the dog started salivating. Okay. And eventually the dog started salivating just after hearing the bell. Even if the food was not given, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Okay. So look at this picture, then you can clearly understand what actually reinforcement learning is. Okay. So before conditioning, it is unconditioned stimulus. This is unconditioned response. Okay. So this is your learning agent, food. That is unconditioned. Okay. So that is response, salivation, unconditioned response. So look, before only bell is there given, neutral stimulus, which has no effect. Okay. So no conditioned response, no salivation. Okay. and during conditioning, bell plus food. Okay, so then unconditioned response. Okay, because food is also present now. But after conditioning, so during the conditioning, this is how you have to train. That is what I am telling you. That is, first exploration takes place when the learning agent acts on trial and error, and exploitation is when it performs an action based on the knowledge gained from the environment. Okay, the environment rewards the agent for every correct action. Okay, which is the reinforcement signal. So look that here. Now after conditioning, bell becomes conditioned stimulus. Although you have not given the unconditioned stimulus food, but the when the dog just hears the sound of a bell, it starts salivating. So that is conditioned response. This is conditioned stimulus. This is conditioned response. Okay. So this is your reinforcement learning. Okay. Because here the environment rewards the agent for every correct action, which is the reinforcement signal. Okay. Now, what is semi-supervised learning? Problems where you have a large amount of input data and only some of the data is labeled are called semi-supervised learning problems. These problems sit in between both supervised and unsupervised learning. For example, a photo archive where only some of the images are labeled. Example, dog, cat, person, and the majority are unlabeled. Okay. So this is semi-supervised learning. Supervised learning, just go through some difference between supervised and unsupervised learning with examples. The computer is represented with example inputs and their desired outputs. Okay, the computer is presented with example inputs and their desired outputs given by a teacher. And the goal is to learn a general rule that maps inputs to outputs. Okay. So you have to, if y equal to f of x, so you have to do mapping of your function, that is f of x becomes approximately equal to y. Okay, when you fed your machine with new input. Okay, so the training process continues until the model achieves the desired level of accuracy on the training data. Okay. Some real life examples are image classification. You train with image or labels. Okay, then in the future you give a new image expecting that the computer will recognize the new object. Okay. Market prediction or regression. You train the computer with historical market data and ask the computer to predict the new price in the future. Okay. Now look at this, unsupervised learning. No labels are given to the learning algorithm, leaving it on its own to find the structure in its input. That is to find the hidden pattern in the input data. It is used for clustering population in different groups. Unsupervised learning can be a goal in itself, discovering hidden patterns in data. Okay. Clustering, you ask the computer to separate similar data into clusters. This is essential in research and science, and also high dimension visualization. Use the computer to help us visualize high dimension data. Okay. Generative models. After a model captures the probability distribution of your input data, it will be able to generate more data. Okay. This can be very useful to make your classifier more robust. Okay, because you need to feed a lot of data now. So this kind of unsupervised learning based model can create um, be able to generate more data, because this kind of generative models can capture the probability distribution of your input data. Okay, so the a simple diagram which clearly lets you know the concept of supervised and unsupervised learning is shown here. Okay, so look, this is supervised learning. Okay, and because these are labeled, look, this is circle label, this is cross labeled, but here you have framed two clusters, but the label is not known to you, so everything either cross or either circle. So that is, you have to assume either everything is circle or everything is cross or everything is something else or mix. You don't have an idea. So the algorithm itself just separates the elements into two different clusters. Okay, into two different categories. Okay. So look, unstructured data, learning the data patterns algorithm that is in case of unsupervised learning algorithm, just learn the data patterns from the unstructured data and give you the results or conclusion. You don't have any predicted or expected output here. No training data set is available in case of unsupervised learning. That is your training, whatever data you are feeding here, that will have no predicted or expected output. Okay. Training data we are feeding is unstructured data. May contain noisy, meaningless data, missing values or unknown data. Okay. Unlabeled data only contains value for input parameters. There is no targeted value. It is easy to collect as compared to labeled one in supervised approach. Okay. So there are two ways to perform feature scaling in machine learning. Okay. One is standardization. Look, x minus mean of x by this standard deviation. Okay. Another is normalization. Okay. When the new value will be x minus mean of x, minimum value of x by the range, that is max of x by minus minimum of x. Okay. So these are the two ways to perform feature scaling, to make the columns unit free. Okay, you can do that. So we will talk these things later. Just I just tried to give you a glimpse on that. Okay, don't need to be worried about it right now too much. Okay. I will talk about feature engineering and feature scaling part later when I do some algorithms, regression related algorithms. Okay. Now we have to learn about data handling parts. Okay. How to prepare the data or how to handle data set. Okay. That is an important thing you have to learn. Look, an outlier is an observation that diverges from the majority of the data under consideration. Okay. Fly high airlines, while studying delays in its flight departures, find that most of the observations in the dataset exhibit delays that lie within 60 minutes of their scheduled departure times. However, two flights were found to have been delayed by 340 minutes. Okay, two flights were found to have been delayed by 340 minutes and by 376 minutes respectively from scheduled departure. These two observations are termed outliers. Extreme values are termed to be outliers, you know, with respect to the observations in the data set. Okay. So what is an outlier? Okay. Measurement errors. Okay, outliers occurs due to various reasons. Okay. Measurement, first one is measurement error. For instance, failure of a weighing machine. Okay. Typographical or errors. Typographical errors means what? For instance, 98.2 was incorrectly typed as 9.82. Unexpected observations. For instance, a survey on slum dwellers happens to erroneously survey a flat owner. Okay. Special causes. For instance, a particular airline flight was delayed by 376 minutes, whereas other flights take off within 65 minutes on off schedule departure. Okay. Other flights take off within 65 minutes of its scheduled departure. The inordinately large delay was caused by a technical problem with the aircraft. Okay. Actual anomaly. The behavior of a fraudulent transaction will be completely different from those of legitimate transaction. Understood? So how to handle these outliers? To handle outliers in your data, in the given data set, the following actions can be taken. Drop the observation, so there is a chance of losing values. So in order to retain the values, you don't drop values. Okay, that is not a good way to handle data by dropping of outliers. Okay, persist with the observations as there. That is also not good, because in that case you will get skewed distribution. Cap the observations, that is the outliers, the closest possible actual value. That is something which you can do, capping the observations at the closest possible actual value. Okay, the particular action taken depends on the situations, obviously. How do we handle outliers? There are a few guidelines to handle outliers in our data. Okay, just go through. Dropping the observations. This approach is advisable only when we are sure that the outliers actually come from a population we do not want to consider. Okay. Persist with the observation. That is the outliers as there. Okay, this approach is advisable if your objective is to identify precisely such outliers. For instance, in case of fraud analysis, anomaly cell detection in medical analysis, okay, etc. Okay, so cap the observations at the closest possible actual value. This approach is the generally advised method of handling outliers. This approach is commonly referred to as outlier capping. The particular action, obviously, the particular action taken obviously depends on the situations. Okay. Now look at the 3 sigma approach for outlier treatment. Assuming a variable follows a normal distribution with mean mu and standard deviation sigma, we know that 99.73% of observations fall between mu plus minus 3 sigma. Okay, we use the above for variable capping, wherein the steps are as outlined below. Okay. Compute the mean, say M for the available data. Compute the standard deviation, say S for the available data. Okay, observations less than M minus 3S and are replaced by the value M minus 3S, and observations greater than M plus 3S, that is mu plus 3 sigma, are replaced by the value mu plus 3 sigma. Okay. Understood? This one. 3 sigma approach. Fly high airlines identifies 3 observations as outliers. Okay. These outliers are replaced by, that is capped at the value 64.80. Okay. This is the value 64.8. So these 3 values will be replaced by this capped value, that is 64.8. Okay. Then outlier treatment can be done using interquartile range approach. What is this? Just go through. Another popular outlier treatment method is through using the IQR. Okay. Compute the first and third quartiles respectively. Calculate IQR Q3 minus Q1. All the observations that are less than Q1 minus 1.5 IQR are outliers. And similarly, all the observations greater than Q3 plus 1.5 IQ are outliers. So outliers are replaced by the closest cutoff, that is by Q1 minus 1.5 IQR or by Q3 plus 1.5 IQR. Okay, the interquartile range covers nearly mu plus minus 2.7 sigma loop minus 2.698 sigma is equal to this, and this is minus 2.698 sigma. Okay. So the interquartile range covers nearly mu plus minus 2.7 sigma for a normal distribution. Thus, for a normally distributed variable, the IQR contains 99.31% of the observations. Okay. Here 99.73 observations are covered when you are using 3 sigma approach, and here 99.31% observation, 99.31% observations are covered when you are using IQR approach. Okay, keep this thing in your mind. Now look, fly higher lines identifies 5 observations as outliers. Okay, so the 5 outliers are replaced by, that is capped at the value 51. Okay. That is 5 values are greater than Q3 plus 1.5 IQR. Okay. So these are capped at 151. That is, these will be replaced by Q3 plus 1.5 IQR. If you compute Q3 plus 1.5 IQR, you will get 51. Okay. So the values greater than those Q3 plus 1.5 IQR will be replaced by this capped value, that is 51. Okay. Now this is an exercise. The data set air delay contains data on flight departures from Las Vegas for January 2008 and February 2008. Okay. The objective of our analysis is to predict delay in flight departures. Use the data to detect outliers, if any of the following variables. Okay. So use the data to detect outliers, if any, in the following variables: elapsed time, air time, distance, arrival delay, taxi in time, taxi out time, departure delay. Use both the 3 sigma approach as well as the IQR approach to cap the outliers, if any. Okay. Okay, I will show you that data. Okay, I will show you, but before that I have to finish these things first. Okay. What is the special value? Often our analysis is done with secondary data. Okay, this means someone else has collected the data and we are just using the data. Okay. You know the difference between primary data and secondary data? I have covered that part. Just remember. When we talk about business analytics part, then we also talk about different way of different types of data and different way when we do statistical part after business analytics part, statistical part, then I talk about different types of data. Okay, so based on the source of collection, okay, based on the source of collecting data, we divide data mainly into two types, primary data and secondary data. Okay, so secondary data which is already used for a different purpose, so now you are going to use this data for a different, for another different objective. Okay, so that is and you have to collect it from some established source, that is from some government agencies or some paperwork. Okay, that is someone else has collected that data for different purpose, and now you are going to use that data for your own use. Okay, so that is secondary data. A few instances of such cases are credit bureau. Okay, that is external data is used for risk analysis of a loan account. Okay, so credit bureau data, and social data is used for our analysis where that data has been collected by a government agency or a market survey team. Okay, often such data contains special values that designate certain specific scenarios. Special values are those values which designate certain specific scenarios. Okay, so how do we handle these special values? Okay, just go through. Suppose we are working with credit bureau data and such data contains a field labeled number of active bank cards. Okay, this data field contains the number of active bank cards, namely debit cards, ATM cards, credit cards, etc. Okay, the data collection agency might wish to distinguish between the following: an individual who does not have a bank card, an individual who has never asked for a bank card, an individual who has lost all his or her bank cards, an individual who does not have a bank account at all. Okay, so hence the data collection agency coded the last three situations: 97, 98, and 99. Okay. So a data collection agency coded the last three situations, 97, 98, and 99 respectively. Assuming no individual can actually have more than 96 bank cards. Okay. Actually, they have no cards at that time. One individual has never asked, one individual has lost all his cards, one individual does not have a bank account. But they are assuming in this way that they have more than 96 bank cards. So they will give such specific values which designate specific scenarios. Okay. So these for our analysis, we must replace these three special values, that is 97, 98, and 99 by 0. Otherwise, it will give us some wrong results. Okay, because when you take these numbers into computation, then it will obviously give you some uh, values of your test statistic, which may mislead to predict the population parameter. Okay, so you have to replace these special values by 0. Okay, now this is another way of handling special values. This is illustration 2. Suppose again we are working with credit bureau data, and such data contains another field labeled months since taken a loan. Okay, this data field contains the difference in months of the time of data collection from the time the last loan was taken. What is what if an individual has never taken a loan? For such individuals, what will be the value of this field? The data collection agency might decide to use a default value, say 999, for such individuals. What will be a more replaceable value? Usually we calculate the 99th and or the 95th percentile of the remaining data. Okay, and replace the default special values of 999 by 99th or the 95th percentile values. Okay, understood? Now types of missing values. Missing not at random, that is also have to learn. Just go through. So types of missing values, missing not at random. Missing values in data might arise due to a variety of reasons. Okay, we need to understand or assume the pattern of the missing values. Okay, missing values might also denote special scenarios. Okay, so Galileo Telecom, when analyzing the behavior of its subscriber base, studies a variable labeled number of minutes of broadband usage on the mobile phone. Okay, number of minutes of broadband usage on the mobile phone. What will happen for a customer who does not have a smartphone? Such types of missing values in data are called missing not at random. Okay. Suppose in the For example, the weighing scale mechanism may wear out over time. Weighing scale. Okay. So you can say the weighing scale mechanism may wear out over time, producing more missing data as time progresses. Okay. So, but we may fail to note these. Okay, if the heavier objects are measured later in time, then we obtain a distribution of the measurements that will be distorted. So missing not at random includes the possibility that the scale produces more missing values for the heavier objects. Okay, a situation that might be difficult to recognize and handle. Okay. Another example of missing not at random in public opinion research occurs if those with weaker opinions respond less often. Okay. So MN missing not at random or MNAR, okay, is the most complex. MNAR stands for missing not at random. So it's the most complex case. Strategies to MNAR are to find more data about the causes for the missingness, or to perform what if analysis to see how sensitive the results are under various scenarios. Okay. Now look at this missing completely at random. That is MCAR. Okay. That is called missing completely at random. So if the probability of being missing is same for all cases, okay, that is all case is getting equal chance of being missing, then the data are said to be missing completely at random. Okay. So it obviously implies that the causes of the missing data are unrelated to the data. Suppose when your weighing scale is running out of batteries, then some of the data will be missing simply because of bad luck. Okay. Another example is when we take a random sample of a population, okay, where each number has the same chance of being included in the sample. Okay. So the one of the data members in the population that were not included in the sample are MCAR, while a convenient MCAR that is missing complete at random is often realistic for the data at hand. Okay. So what there? So there is another concept, that is MAR, missing at random. This is slightly different from the missing completely at random. What is the difference? If the probability of being missing is the same only within the groups defined by the observed data, then the data are missing at random. Okay, so missing at random, that is MAR, is a much broader class than MCAR. For example, when placed on a soft surface, a weighing scale may produce more missing values than when placed on a hard surface. Okay. Such data does not MCAR. If, however, we know surface type and if we can assume MCAR within the type of the surface, then the data are MAR. Okay. We have to assume MCAR within the type of surface. We know the surface type now, hard and soft. Okay. So these type of data are called MAR, that is missing at random. Another example of missing at random is when we take a sample from a population where the probability to be included depends on some known property, like some known attribute. A missing at random is more general and more realistic than MCAR. So look at these types of missing values. Okay, missing completely at random. Okay, if the pattern of missing values does not depend on observed or unobserved values, then we call the pattern as missing completely at random. Okay. Uniform non-response or uniform unavailability of data means you cannot know the reason. Okay, the probability of being missing for is same for all the observations you are going to collect here. Okay, you don't know the reason. Okay, to which you can relate the missing values with your data. Okay, to which you can relate missing values with your observations. You don't know the reasons. Okay, here. You don't know the reasons or causes to which you can relate the missing values with your data or observations. Understood? And MAR is a broader thing. That is a broader MAR, that is missing at random, is used in a broader sense compared to this MCAR. Okay, where within the group the MCAR is known, but between the groups, you know the type of the group which does not make the observations which does not make the missing observations completely equally likely. Okay, that is the probability of getting selected is not completely at random. Okay, that is missing at random depends. That is, you know, the suppose your weighing scale on a soft surface give more missing values, okay, and on hard surface gives less missing values. So you know the surface type here. Okay, one factor is known, but within that surface, whatever data or observations you are going to collect, there may be chances of some values of being missing, because within the group the observations selected are MCR. Okay, that is completely that is missing completely at random basis. Okay. That is, if the probability of being missing is same only within groups defined by the observed data, then the data are missing at random. Okay. But the group, the levels of the group is known to you. That is hard surface and soft surface. That is the level of your group now. So that is known to you. So you cannot say it missing completely at random. But within the group, the probability of being missing is same. Okay. That is MAR. Okay. Now look here. If you drop these these missing values, okay, assuming that the missing values to be MCR, that is missing completely at random, then the inferences made out of the observed data are not affected. Okay. Now look at this part. Types of missing, that is MAR, what I have told. Missing at random. Just go through. In a clinical trial, if the patient withdraws in the middle of the trial, okay, then the variables post withdrawal will have missing values. Okay. If we assume that the withdrawal happens at random, that is within the particular group. Suppose there are two types of treatments are going on, and within that, treatment A and treatment B are given. Okay, but within that group, whatever be the withdrawal happens, whatever be the withdrawal of patients take place, that is at random. Then the pattern of missing values in the data becomes missing at random. That is MAR. Okay. So we prefer assuming MCAR to be as MAR in most data mining exercise. Okay. Now missing value treatments, traditional approach under the missing completely missing completely at random pattern assumption of missing values. Okay, the traditional approach is to delete the observations that have missing values. Okay, such deletion could be through two methods: list-wise deletion, pair-wise deletion. Okay, if the data for any variable is missing, the entire observation is removed from the analysis. Okay. And in pairwise deletion, in bivariate or univariate analysis, an observation is removed only if data for the variable or variables under consideration are missing. I will just give you an example. I will cite one example that you can understand. Suppose you have a table, okay? You have user A, B, C, D, F, G, okay? And another column device, okay? And suppose, how can I say? Okay. I'm showing one example. Just wait. Just wait. look, this is the table, okay? And, okay. So this is the table. Here you just look. This is your this is a table comprising user, device, operating system, transactions. Okay. So look, the two tables above give different insights. Okay. The inference from the table on the left. Okay, the inference from the table on the left with the missing data indicates lower count for Android mobile users and iOS. Okay. Tablet users and high average transaction value compared to the inference from the right table with no missing data. Okay, look, if you compute this, mobile Android, okay, so you will get 2 and tablet Android 2. Look, mobile Android 2, tablet Android 2. Okay, mobile iOS only 1. Count them, okay. And the tablet iOS is not present because no matching device for C and F user. The device is absent from the table. Okay, so in this way you just look the average transaction. Okay, so this is your 5 plus 3, 8. Okay, so 8 by 2 because 2 Android devices are used. Okay, so that is, so this is and 3. Okay, just wait, we have to compute all. So 5. So this is your for the 0. Okay, so tablet iOS, just look. Tablet iOS is 0. Okay. So look, 5 plus 3 plus 4 by 3, that is 4. Okay, and then look at this tablet transactions 1 and 4. 4 plus 1. Okay, 4 plus 1 by 2, that is 2.5 transactions. Have you understood how will we compute these average transactions for all the mobile transactions? That is 5 plus 3 plus 4. Okay, divided by the total number of mobiles. Here 3 times mobile device has appeared. So 5 plus 3 plus 4 by 3. 4, and this is 2.5 because tablet appears twice and the corresponding transaction is 1 and 4. So 4 plus 1 by 2, 2.5. Okay, now come to the right hand table. Come to the right hand side table, that is that calculates also. Look, there is no missing data. So mobile Android is 3. Okay, mobile iOS is 1. Tablet Android is the combination of tablet Android is 2. Okay, and the combination of tablet iOS is 1. Look at the C user. Okay, that is tablet iOS. Okay, so again 5 plus 3 plus 2. So 5 plus 3 plus 2, so that is your 10. Okay, is there any mobile Android? No, so 10 by 3. Okay, and okay, also mobile iOS needs to be checked. Okay, I have to consider mobile iOS because it is the average transactions for mobile device. So 5 plus 3 plus 2 that is for mobile Android, and for mobile iOS, that is 4. Okay. So 5 plus 3 plus 4 plus 2. So that is equal to 5 plus 3, 8 plus 4, 12 plus 2, 14, and divided by 4. Okay, because mobile device used here appeared here 4 times. Okay, so 14 by 4 is what? That is equal to 3.5. Okay. So 14 by 4 equal to 3.5. And now look at this tablet part. Okay, for the tablet Android, that is how much? Tablet Android 1. Okay, and this is 4. So 4 plus 1, and there is a tablet iOS that is 1. So 4 plus 1 plus 1, 6. So 6 by 3, because 3 times tablet is used here. Tablet device is used here 3 times. That is, tablet device has appeared here 3 times. Okay, thrice. So you have to divide the total number of transactions for tablet device by 3. So 4 plus 1 plus 1, 6 by 3, that is your 2. Okay, that is the average transactions. Okay, now look at this, the inference from the table on the left hand side. The missing data indicates lower count for Android mobile users. Okay, and iOS. Okay, tablet users, and higher average transaction value compared to the inference from the right table with no missing data. The inference from the data with missing values could adversely impact business decisions. Okay. So the best scenario here is to get the actual value that was missing by going back to data extraction and collection stage and corresponding and correcting the possible errors. Okay. So what is this technique? I have told you deletion and list-wise deletion and pair-wise deletion. So look at this. So look here, what we will have to do here. Unless the nature of missing data is missing completely at random, the best avoidable method in many cases is deletion. So list-wise is that, list-wise deletion is what? In this case, rows containing missing variables are deleted. Okay. In the above case, the entire observation for user A and user C will be ignored for list-wise deletion. So what is pair-wise deletion? In this case, only the missing observations are ignored and analysis is done on variables present. Okay. You have to consider the variables, okay, present, but only the you have to delete the missing values. Okay, you have to ignore them. So in the above case, Two separate sample data will be analyzed, one with the combination of user device and transaction, and the other with the combination of user OS and transaction. Okay. In such a case, one won't be deleting any observation. Each of the samples will ignore the variable which has the missing value in it. Okay. Understood. Each of the samples will ignore the variable which has the missing value in it. So you have to create two separate sample data for analyzing. Okay. So both the above methods suffer from loss of information. List-wise deletion suffers the maximum information loss compared to the pairwise deletion. Okay, but the problem with pairwise deletion is that even though it takes the available cases, one cannot compare analysis. Okay, that is, one cannot compare the analysis because the sample is different every time. Okay. So you have taken two different samples. So every time when you are going to choose the sample, that will become different. Okay. So this is the main reason, that is pairwise deletion will be not good. Here also some sort of information will get lost, but it is better compared to list-wise deletion, because in the case of list-wise deletion, have to remove the entire observation. Okay. Now look at this. Now missing value treatments for by using this method, single value imputation. Just go through. Understood? You can impute the missing values by a representative value. Okay. You can impute the missing values with a by a representative value provided the data is missing for just a few observations. Okay. So if your variable has missing value for more than 8 to 10% of observations, it is better to drop the variable from our analysis. If the variable is a discrete variable or an ordinal variable, then we impute the missing values by the median of the available observations. If the variable is a continuous variable, we impute the missing values by the mean of the available observations. If a variable is a continuous variable, but we know from our experience that it is clearly not normally distributed, we impute missing values by the median of the available observations. If a variable is a categorical variable, a nominal variable, we impute the missing values by the mode of the available observations. Okay. And this is an illustration. Look at this part. Just carried out some univariate analysis. Just obtained the following outcome. Okay. This is the percent of observations. Okay. What are the variables? Household income, household size, marital status, children, number of children. Okay. So distance from the store. Okay. So these are the total number of observations, and then come number of missing observations. So what is the percentage of missing observations? And mean from the available data is this. Okay. And then median from the available data is this, and mode from the available data is this. Okay. Look here, for the categorical variable marital status, the mode is married. Okay. So it appears most of the time. Okay. Mean and median cannot be computed for the categorical variable marital status. Okay. So what is your imputed value? Okay. So you can give this imputed value. Look, here you can choose median because median is lower compared to mean. Okay. You choose, and the missing value of observations are not 8 to 10% of observations. It is almost within 2 to 3%. Okay. Only in this case 15.0%. So drop this variable. Okay. Drop the missing values of this variable. Okay. Not all the observations, drop the missing values. Okay. Don't impute any values for the missing ones in that variable children. Okay. So this is your marital status, that is mode, is the imputed value for missing values. And 3 is the imputed value for missing values in case of variable household size. Okay, because it is median. Okay. Here we consider the mean for variable distance from the store. 5.12 is the imputed value for missing values. Okay. And you have to drop missing values for variable number of children. Okay. Understood? Because look at the percentage of missing values here, 15.0%. Okay. So you have to go with the first thumb rule. That is, if a variable has missing value more than 8 to 10% of observations, we drop the variable from our analysis. Understood? So single value imputations limitation. Okay. These are very important things. I cannot cover all these things today. Look here. After imputing the missing values by the median, this Julia wants to look into the distribution of the household income again. After mean impute, this is your original data and this is your after mean imputation and after median imputation. Okay. Look, the mean value gets changed by 2.3%. Okay. When you impute median value for missing values. Okay. Look at this value 26.983. So single value imputation limitations, just then plot the variable distributions of income for available distribution for available or means for the original data. Okay, distribution for of income after mean imputation and distribution of income after median imputation. All are still positively skewed distribution or right tail distribution. Okay. Julia wants a solution that will not change the distribution of the original value. Okay. Then Julia adopts the following approach. Okay. Julia divides the entire data set into 10 or 20 equal groups based on the observed values. She then finds a representative value from each group. Julia takes the median of the group as representative. The mean would also have been a viable alternative. Okay, each time she finds a missing value, Julia randomly draws a number from the above 10 or 20 groups. Okay, that may be median or mean, whatever you want to choose for each group. Okay. So random value imputations, okay, just Julia obtains the following result. Okay. So if you do some random value imputation, then Julia is happy that the distribution of the variable has not changed. Okay. So whether you put some random value or some median, okay. Look, after median imputation or after random imputation, there is no as such change. So in order to deal with such data where you will find the data after imputing median or some random number on your missing values, you are still getting right tail distribution or left tail distribution. Okay, then you have to go with the box cox transformations. Okay, I'm not covering this part today. Okay, I will cover that in the next session. Okay, that is an important part that you have to learn. So today that's it. Anish, are you there?